look at some programs which can be used to collect statistics about the program that we want to understand what takes time in. And these so-called profiling tools are the following. And operf, that only works on Linux. There are similar tools on Mac OS and Windows. For Windows, you can look at Intel's website. They usually have a version of their performance analysis tool. Look at products and then software, and then you can usually find something that is free for personal use or free for students. Okay, and in Xcode there is, at least there were, and I'm sure there still is, similar tools as operf. Okay, gprof. The G here is not for GNU, but it's for graphical. But and this is a tool developed at Berkeley. And gcov, it is the GNU version of a program called tcov. And tcov stands for test coverage, which can be used to check how many times each source code line has been executed. And more importantly, if all the if all the source code lines have been covered in the tests. So that's the meaning of that name, of that program. Okay, perhaps the most important profiling tool is actually printf, where you, of course, it doesn't give you execution time, but it gives you with the proper counters, you can collect interesting statistics to draw conclusions about your code that can be used to improve it in some creative way. When you use printf and a counter variable, be sure to use unsigned long as the type. If you only use int, then there is always a risk that what is printed is just garbage due to it has the type was too small, so it was wrapped around and it's irrelevant information. So you can use, for instance, a type test like that. So operf first. Modern CPUs have something called performance monitor counters, and what this is, that it's a relatively small set, such as 4 registers, that can be programmed to count how many times a certain event has happened. And what is interesting, of course, is not when you have, consider the following, that you would run the program and then it tells you how many times there was how many clock cycles or how many instructions were completed. That's maybe interesting, but what this is much better. Namely, that it measures this for each instruction. Instruction address in the program. So by sampling the program counter when a certain number of such events have happened, we can get very accurate statistics. The more accurate, the longer we run the program, of course. How long do you need to run the program? Well, there are two things to consider. First, if the program needs some startup time before it enters the important part, then of course we must wait until that phase of the program has been entered. And secondly, even if it starts immediately, we should at least run a few seconds, but preferably more. So what is it really that happens? Well, we say how many such events, for instance, clock cycles or instruction cache misses, or number of times data is transferred from memory to a cache. When a sufficient number of such events have happened, then an exception is triggered. An exception is, in this course, I mean not in object-oriented programming, but it's a hardware exception. And what happens is that the processor jumps into the operating system kernel and it requests help from the kernel to handle the situation. Exceptions happen, they can happen due to a program error, such as the segmentation fault, when you have an invalid pointer that you read through or write through. Or it can happen that when data is not in memory, but instead it has been moved out to the hard disk and it needs to be moved in. That's an exception called a page fault that triggers this. Since the CPU cannot fetch data from the hard disk, it's much better, of course, to let the operating system handle that. I mean, otherwise it would be completely absurd. Okay. So what happens when we get an exception? Well, since it is the operating system which takes over, the CPU state changes from user level, which is when we run our programs, to supervisor mode, or user mode to supervisor mode. And then it saves the program counter where it was, partly so that it can return in the proper place, but for the performance monitoring, it saves the program counter to collect statistics about this address, where it was. And then when we collect these statistics, it will be sufficiently accurate to understand which program counters are I mean, which instruction addresses are those which take the most of the time. I mean, where the program spends most of the time, at which addresses, and therefore at which source code lines as well. Okay, so to run operf on, well, I should mention also which. This is a funny, okay, we can say this one is clear what it means. Transfer data from memory. Here we get an instruction cache miss. Here we have run an instruction to completion. I mean, it leaves the reorder buffer. And this one is the number of clock cycles. This one is, actually what it means is transaction begin. The Power 8 is a machine which supports something called transactional memory, which is covered in the multi-core programming course. It's a way to write parallel code which does not need locks. Okay, but I will not talk about it. It behaves like transactions in databases, but I will not talk about it more in this course. Okay, so to install this on Linux, we simply do as follows, and this is to set a certain bit so that we can do this performance monitoring. Okay, and when we want to measure something, we run operf, the name of the event type, and then how many of these counted events should be counted, and then when this counter has come to, I mean, when it has counted this number of events, it will trigger the exception. So what should we do? How should we put the number here? If we have a smaller number, then we get somewhat more accurate information, so to speak. Well, it's not necessarily true, because there will be more overhead due to handling the exceptions. And if we have a very huge number, then the accuracy of, we cannot so easily understand at which instruction address the counted cycles actually happened. So some reasonable number here. Then this one can be skipped, and the next one is it should be 0. If it's 1, then we should also measure what's happening in the kernel, but we are not allowed to do that. You need administrator privileges to do that. But this one here, it measures what happens in the user code. In your code. Okay, and then we give the program name and arguments, which in this case says that it should run with systems with 15 variables and inequalities, but that's just my version of this one. Okay, so we get the output in a directory in this with this name, but you don't have to look into this directory. Instead, you use this tool and another one, op report. What this says is that it should report about functions which take at least 0.7% of the execution time, and it should provide a listing here of these functions. Okay, so if we do this for intopt, and this is exactly the same version as the pseudocode, translated in simplest possible way into C code. Okay, so we can see that the pivot takes most of the time, and the others like that. Okay, so if this was without optimization, and with optimization, it's still the same, that this one is the most time consuming, and that's because almost all of the floating point operations are performed there. What we also can see is that this X simplex has got a new name, and what this means is that GCC has done something which is called cloning, and what it notes that one parameter to the function is a constant, and then it can create one copy of the function with a known value of this parameter, and optimize it better when it knows the value. Okay, so therefore it has a funny name here. So even if we have slightly different percentages, it's still the purpose is to find which function takes most of the time. Okay, so if we now want to, well, I should also say that of course we should use with optimization, because that is what we do when we run it for real, so to speak. But for this tool, op annotate and -s, the S is for source code, the A can be used for assembler code. Then it's easier if we don't optimize the code. I mean, if we don't use GCC with optimization. Optimization can make these measurements a bit weird, since code from different statements are interleaved, and it can therefore be much more preferable to use op annotate if we don't optimize. So the code will make more sense. I mean, the numbers here will make more sense. Okay, recall it's gaining insights, which is interesting, and not the exact numbers. gprof Okay, I should say one more thing about operf. And a big advantage with it is that we can run any program just as it is. You can try, for instance, operf on GCC if you want that. So you don't have to use any special flags to use operf. It just samples the program counter and sees what happens and collects this information. Okay, gprof on the other hand, it can count the number of times each function, not only can, but it counts the number of times each function is called and by which other function. Okay, so gprof collects timing information about how much time in a particular function. So in the pivot it was this number of seconds, and then for x simplex it was this, and we can also show the sum of this. Okay, and the number of calls and the time in itself, and also including calls that this function made. So x simplex, it doesn't take very much time in each call, but if we include the functions that it calls, it will be this instead. Okay, so what is this? It's we get 2 parts of output from gprof, and this is the first, and the next one is this, where we can see how many times a function calls other functions and which function called our function. So if we look at this function to suck, we can see that it's called by intopt. Intopt makes all, I mean, of the 3,518 calls, intopt does all of them. Okay, suck, it does, it calls simplex 3,518 times, and intopt, well, we know it was intopt which also called simplex. So most of them, we know how many times of all that a certain function call. So those which are above this function, it's those which call the function, and those below is what this function calls. This can be very, very interesting information. So it's really good to check these things. If we instead want to know how many times each line has been executed, then these are not, operf and gprof are not sufficient. And the reason is that to count the number of times we are in each line, the compiler must produce code to count that. Okay, and we do that with GCC like this, as extra flags, and then this is, and then we use gcov and simplex, and okay, at that time I had put the simplex and intopt in separate files, but view this as well. This is just the simplex part, but it doesn't matter. Okay, so we give this a C file, and it produces this file. And we can see how many times it is in each row. And this is, of course, extremely interesting, so that we understand that maybe some part of the code which we thought would be unusual, if it happens quite often, then we have just learned something new. And we should investigate why that happened. We can also get the branch statistics with this. So what this says is that one of these is taken more frequently than the other. Okay.